This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hi, this is Philip Winston for Software Engineering Radio. My guest today is Timothy Beamish. Timothy has been a software developer for more than 20 years with a focus on front-end architecture. He's currently a staff engineer at BenchSci, overseeing a suite of front-end applications written in React and Next.js. Prior to BenchSci, he was a senior staff engineer and web team lead at Plenty of Fish, one of the largest online dating sites. Welcome, Timothy. Is there anything I left out of your bio?
No, I think that's good. Yeah, front end mostly focused, dipping into the back end a little bit, and yeah, built tons of websites over the last few years.
Great. So let me just set the stage for the show a little bit. So React is a very popular open source front end library, I'll say, released by Facebook in 2013. And Next.js is a framework for React released by Vercel in 2016. So we're going to divide the show into three parts. First, we'll talk a little bit about React itself with an eye towards the following discussions. Then we'll talk about Next.js and go through a number of features and discuss the advantages and some of the disadvantages of Next.js. And finally, we'll talk about a recent migration to Next.js that Timothy oversaw at his current company. This part of the show is based on a blog post of Timothy's called Moving House to Next.js that we'll put a link into the show notes. I also wanted to mention that Timothy and I both currently work at the same company, although kind of at opposite ends of the company, so we don't really encounter each other day to day. Before we dive into React, I want to highlight a previous software engineering episode that discussed React in pretty good detail. Episode 382, Michael Chan on learning React.js. So to start off, is React a framework or a set of components or a library? How would you characterize React?
React is a framework for building front-end applications. And it's important to know that it only does one thing, and it does that one thing well. It doesn't do everything. It doesn't solve all the problems of the front end. Its job is to take data and represent that as a state via UI. So it's just places a bunch of UI on the screen, which is telling you what your data situation is currently in the front end. As soon as that data changes, the front end changes, the UI changes. And that's pretty much all it does. There's lots of other problems you have to solve on the front end, and React doesn't solve any of those for you, which is where kind of Next.js comes in to help out a little bit. It helps solve some of the other problems.
I saw the name React and looked it up, and it said it's kind of based on reactive programming, which is kind of what you were saying, the ability to handle updates, data updates to otherwise static content. Is that a fair characterization?
Yeah. So in the days before React, in fact, in the days of static web pages, when the web was pretty boring, you'd go to a web page, it would render. If you wanted to go get some new information, you'd have to render a whole new page again. Then Ajax came along, and that blew up the internet. And it meant that web pages didn't need to load in entirety to change themselves. They could dynamically shift over time without loading the whole page. Little pieces could reach out and ask questions of servers, get answers back, and re-render just portions of the internet. And this opened up web pages to be dynamic applications. But it also creates a lot of complexity because now you've got to manage which parts of the page are updated, what the state of different parts of the page. Different parts of the page have to be in different types of state. You have to have some sort of global management system to handle all that. And we had tools like jQuery to help us kind of paint things on the page, but it didn't help us organize the data. And then things like Angular and React came along as solutions to this problem. And then for a little while, we had massive front-end framework wars. And these days, React kind of stood out as the leading way to do this. But basically, its job is to manage the data that's coming into the application, the global state of the application, and allow you to represent that using UI. So it'll figure out which parts of the pages need updating, which parts don't. And you don't have to worry about making sure that everything's in sync. You just make sure that your data is correct and that you have a good mapping to the UI.
One React concept is components. Are these visual components you can point to on the screen? Are they more generic than that? What is a React component?
By and large, yeah, they would be visual components, although not always. You can have components that are hidden in the background that don't actually render anything. But generally speaking, a component is a little piece of UI that gets some data sent to it, or it holds on to some internal data. When it gets data sent to it, that's called a prop or a property. And when it holds on to internal data, that's called its own internal state. And it'll render something to represent the props and state that it has. So maybe if the component is meant to represent a button, and the button needs to be red in some cases and green in other cases based on some information coming into it, the component's job is to say, hey, I take a property that tells me whether I'm on or off, and if I'm on, I'm red, and if I'm off, I'm green. And the thing that talks to me only has to know whether I'm on or off. It doesn't have to know anything about red or green. That's my job to handle that on means red and off means green. And I will take care of that. All you just make sure that the data flowing into me tells me whether or not I should be on or off. And that's kind of what a component does. Now you can have, that's probably like the simplest form of component. There's a few different types of components, and the more, I guess, trickier ones would be things that have to fetch asynchronous data to update the application. So some components, their job is to say, hey, I need to get some data to render my self property. We don't have it. I need to go ask a server for some data. So it has to do some sort of asynchronous operation. Then it becomes more complicated. It has to handle things like, hey, I'm asking for data now, but I still need to render something. So I need to render the fact that I'm asking for data. So I would typically put like a loading spinner on the page.
So when we say render, in this case with web browsers, we're talking about emitting like a chunk of HTML that's going to fit into the page somewhere, and then the browser renders it perhaps at some rate.
Yeah, rendering is painting pixels onto the screen, and unfortunately, it tends to be a rather expensive operation. So one of React's superpowers is that it holds on to a copy of what the UI looks like in the background. And it's called the shadow DOM. And React is able to update the shadow DOM. The shadow DOM is like a giant tree. So it'll update a piece of that tree, and it knows that the stuff that's on the screen is one tree. My shadow DOM is another tree. They should be in sync. And I know that because I've just updated my shadow DOM, there's a little piece of it that's now out of sync with what's on the screen. I need to repaint just that little piece. So I don't need to repaint every pixel on the screen. I just repaint that one little piece. That's a big benefit because, as I said, painting the screen is expensive. So if I only have to paint a little portion of the screen, I'm doing much better. And that's kind of where React's superpower comes in. So it uses the shadow DOM to figure out what parts of the real screen do I need to paint. And then it does the process of rendering, which is, like you said, putting pixels in the right color in the right place on a screen.
And the DOM is the document object model that's kind of like the HTML tree.
Yes, exactly. So if you crack open any web page in Chrome, you can hit F12 and go into your developer tools and look at how a web page is built. It is in a document which is structured in what's called a DOM, which stands for Document Object Model. And it's basically a tree. So it starts at the very root, and the very first tag will be your HTML tag. And then that tag will have, that's the root of your tree. It'll have some children. Typically, the first two children that it has is a head child and a body child. Although it doesn't necessarily have to have that. You could have some more things. And then in your head child, there's information that represents kind of metadata about the document. And then in your body child is kind of the representation of what you see on the screen. And so that's all split up into HTML tags. And those tags organize the structure of the document. And then CSS is cascading style sheets is the technology that decides what that structure is meant to look like in terms of what colors and formatting and things has. And React organizes all of that for you. So instead of thinking about it in terms of HTML elements and CSS tags on things and CSS attributes on things, you think of it in terms of components, which are building blocks that still live in a hierarchical tree-like structure, and they have styling glued into them, and they get represented in the ethereal world of React. They get updated in the shadow DOM, and then React says, hey, my shadow DOM's changed. I now have to go repaint different HTML on the front end.
How about JSX, JavaScript Syntax Extension? I think that's not specific to React, but maybe it's used with React. Have you used that?
Yes, it's funny because so we write React using JavaScript, and when you use the JSX extension, it looks like you're writing HTML inside of JavaScript, which kind of breaks your brain a little bit, but that's not actually what's happening. I would say JSX is an extension of JavaScript, is a better way of saying it. It allows you to write what looks like HTML inside your JavaScript program. So normally in regular JavaScript syntax, you can't define a piece of HTML and assign it to a variable. You'd have to write the HTML in a string, and the content of your variable is actually a string. With JSX, you can write a component which uses a similar type of syntax as you would see in HTML, and that actually becomes the content of your variable. Under the hood, it's actually just building classes and passing around functions that produce classes. But JSX allows you to abstract that away. And so visually, you look and feel like you're building an HTML-like document using tags and attributes, when in reality, under the hood, it's getting transformed into functions and classes.
Since React came out of Facebook, I think I would imagine one of the benefits of components is being able to have a bigger team work on a single application, but maybe have components that are reused. Is that part of the benefit of React, that it can enable this kind of reuse?
Yes, absolutely. You hit on a great point. So in the old days of HTML, if you had a button on the top of the screen and a button on the bottom of the screen, and they looked the same, but they did different things, you'd have to write that code out twice. With React, you would make a single button component, which then you can use all over your site. And that single button component, I mean, you want it to do different things in different situations. So you would pass in some property to a instance of that button to say, I want you to execute this function when you get clicked. And this other one, I'm going to create you look exactly like the other one. I'm going to reuse this component, but I'm going to pass in another function to you to say that when you get clicked, you do something slightly different. So yeah, it allows for tremendous reuse, which helps you organize your code base, makes you far more efficient, and helps teams work together much more efficiently.
Let's move on to Next.js, and we can still reference React features to compare them to Next.js or just sort of go between the two. But let's talk about Next.js and what it adds. I'm going to start with this data fetching and client-side rendering and server-side rendering, just kind of comparing those, and which does Next.js favor or which does it encourage, or which styles are common.
Okay, so Next.js doesn't necessarily solve the problem of data fetching for you. So this is a pretty big problem in the React ecosystem is like I said, React is good at, you give it some data and it renders it to the screen. But how do you get the data in the first place? React doesn't have an opinion on how you do that. There's lots of different ways to do that. Next.js doesn't necessarily solve that problem either. So there's lots of different ways to do data fetching. And typically data fetching is when your software needs to know something, so it reaches out to an external server, usually an API server, asks it a question via an HTTP request, and gets back some data. And this is kind of the principle of Ajax. This is what kind of turned Web 1.0 into Web 2.0. And there's lots of different ways to do it in React. Probably the most popular way is a library called Axios, which it's an older library, but it's bulletproof. It works in more browsers. It has tons of features. The new way, the future, is using an API called Fetch, the Fetch API, which is built into the browsers now. But more people that I found are still using Axios because it still is a little more feature rich and works in the weirdest of places. It's been around a little longer. The old school way of doing data fetching is actually making XHR requests, which is old and convoluted, and we now have lots of frameworks built on top of that. So you don't have to deal with actually like the guts of Ajax, which is building XHR stuff. So the newest, coolest way of making data fetching requests outside of Axios and Fetch is a framework that kind of encompasses both of those. And at BenchSci, we use something called React Query. React Query is a library built for React that is meant to handle your data fetching stuff in a React context. So it uses this concept of hooks, which is a newer React mechanism where a component will call a series of hooks, one or more or zero, before it does its rendering. And those hooks are meant to perform procedures. And in one of those procedures, you can invoke React Query, which has a clever caching system built into it and knows if I can't find something in my cache, then I need to reach out to an API server to get the information I need. And then I can send that back. So the output of the hook, when you always call the hook when you render the component, the output of the hook is the contents of React Query, which is either going to be, go away, I'm loading, or here is some data for you, or there's been an error happening. And so your component then either has the data it needs, it knows what to do, or it can render a loading state, or it can render an error state. So I should mention React Query sits on top of the Axios system or the fetch system, or if you really are crazy, you could do it with the old school XHR Ajax system. And most people use Axios as far as I've seen.
So let's talk for a little bit just about where the need for another framework came from, or how Next.js came to be, or how you came to discover Next.js, and kind of just from a high level, what sort of benefits does it provide? I think the data fetching is an example of how there's a lot of choices there and a lot of options. But just from like a high level, if I were considering using Next.js, what aspects of my project would steer me in that direction?
So as I've said, React only solves one part of the front-end problemscape, and it does a good job of that. Next.js comes along to offer you some opinions on how to set up a React application. And so it kind of makes things a little more rigid and concrete for you. So one of the things that it provides out of the box, which is pretty nice, is a nice routing system that's really easy to kind of understand and comprehend. Routing is the relationship between what is the address in your URL, like in your browser, in that URL bar, what is that address in relation to what is on the page? So we've now moved to single page applications on the internet, which means when you load up a website and you traverse through that website page by page by page, you're not actually, in a lot of cases, making full requests to get back full web pages and render those. What's happening is you're just saying, hey, I want to travel through this website, and my state is just going to update and change as I'm traveling from place to place in this website. The route needs to reflect that I am now at this point in the website. Now I'm at this point. Now I'm at this point. I need to have a route that reflects that, so that if I want to leave this website and then come back to this one part of it, I have a way of getting there, which is what the route is. I can bookmark that route, I can save it, and I can call up this website and get to that state again. So routes have now changed because in a single page application, you're not necessarily downloading a whole new page. You're downloading the first page, and then you're transitioning your state to be where it needs to be aligned with whatever the route is. Does that make sense?
Yes, I think so. So at one point, the URL corresponded strictly to subdirectories in a file system. And if we're running a single page application, that's no longer true, but the different components of the URL still need to point to something, but maybe they're pointing to something within the application.
You got it. Right on. So what Next.js does is it helps solve the complexity of the routing issue. Previous to Next.js, I think the most popular library would be React Router, which enables you to build a routing system in your application, and it's usually one of the first things you do. So yeah, I'm going to create a React app, and the very first thing in your React app is like your top level component. And in there, you will stick your routing system, which will say, okay, the very first component that loads is my outer shell. It's usually called the app component. And then somewhere pretty soon after that, I'm going to define all my routes. So Next.js, this works and it's nice. Next.js says, hey, we're going to offer you something a little different. We're going to, because you're used to file folder structures being represented as routes, we're going to offer that back to you. So Next.js gives you the ability to structure your Next.js app. In your file folder structure, you can have a folder for all of your different routes, and your routes follow whatever that file folder structure is, so that you end up in your file folder structure. If you have, I'm at subdirectory A/B/C, then that means that the page, my website /A/B/C will be an actual page. And you can stick a page component in that folder structure. Next.js will look at that file folder structure. It'll extract out the hierarchy of it, and it'll turn it into a set of React routes for you, and it'll paste it into the top level of your app. So you don't have to worry about setting up routes programmatically anymore. You just do it using your file folder structure.
So we're talking about single page applications, but then in this case, does that imply it's multiple pages when you're talking about the subdirectory corresponding to a route? I guess just trying to understand, is single page application the most common way, or is it a required way to do sort of Next.js applications?
Okay, this is interesting because in a single page application, technically there is only one web page. But humans like to organize things as when I click on a button and I go somewhere else, or I go somewhere else. In actuality, what's happening is your state in the application is changing. You're not necessarily loading up a brand new web page. You're still on the same web page, but you're seeing a completely different state. And to help humans kind of resolve this, we use the terminology, hey, you've gone to a new page in the website, but that's not actually true. You haven't downloaded a brand new page. You've just updated the state in that page. So in the olden days, yeah, sure, you'd have to, if you were to go to A/B/C, you would be downloading the C page. And if you were to go to A/B, you're downloading the B page. That's not true here. So yes, we are always on the same page. A single page application is only ever one page. It has to update its state to get to the right state, which is aligned with the route that you're on, the URL that you're on, and all that is to help humans kind of resolve the fact that they think they're moving around to different pages when in actuality they're not. It's just a state update happening in a single page React app.
Maybe this is related, but I came across a concept called dynamic routes. Is that building on this, or is that a different type of route?
Sometimes, let's say I want to go to A/SomeID/C. So let's say we're looking at a shopping cart or some sort of shopping site, and you want to look at all the products in the winter section. So maybe you want the URL to be products/winter/list, and that will list all the products in the winter section of this department store that you're looking at. But maybe they have a summer section as well. So maybe you want to go to products/summer/list, and you'll get all the summer products. Now, the list of summer products and the list of winter products, you could abstract them to say that they're going to be really similar. Like it's a list of things, and some of them are summer in one case and some of them are winter. So the fact that you could flip summer and winter. So summer and winter becomes this kind of dynamic piece. In a React app, you could say that we're actually going to render the exact same pages and exact same components. And all we need to do is change one little piece of data in the back to say, hey, database, get me my winter products and I want to list those, or get me my summer products and I want to list those. And so in the route up in the URL, the dynamic piece is the variable that represents winter and or summer. In Next.js, you can do that by updating your file folder structure and using a special piece of syntax, just chucking some square brackets around a folder to indicate that that folder is going to have a dynamic property about it. And so Next.js can easily say, oh, this is a dynamic folder. I'm going to turn this keyword that you used inside those square brackets, the name of your folder, I'm going to turn that into a variable, and I'm going to feed it into whatever component is downstream from this folder. So when you load that component up, it's going to get a variable, let's call it season. So maybe you've named that folder square bracket season ending square bracket. Then your component's going to get a season variable coming in, and you can assume the value of season is going to be either winter or summer. And if it's not, you can throw up an error saying you've picked the wrong season. And if it's winter, then the React component downstream from that is going to ask the API, give me all the winter products. If not, give me all the summer products. And then it's going to generically do the same thing. All I'm doing is asking for a set of products, and I want to then render them to the screen.
So with season, there's only 4 seasons, but I think what you're saying is that dynamic portion of the route could correspond to anything in the backend or in the database, and there may be hundreds of flavors to deliver. And so, yeah, representing that as static pages would be impossible, I guess. So that seems like a big advantage.
Yes, you're right there. I tried to give you a trivial example with seasons, and yeah, there's only 4 of them. But yeah, you could scale that up to names of people or something, which could be theoretically infinite.
Okay, so we talked about routing and how Next.js does that differently than React by itself. Another concept, we've talked about rendering, but is the difference between client-side and server-side rendering, and what is Next.js providing there, or what is its opinion on which is the better approach, or which approach should I consider in which case?
There's a lot of interesting things to touch on here. First, I think we should probably define client-side rendering versus server-side rendering. And then there's a third one, which is called static rendering, also called pre-rendering. So there's three kind of ways to render an app. So I'll first just touch on what each of those are, and then I'll go into the benefits and drawbacks of each of them. So client-side rendering is kind of the very first in the evolution of single-page applications. Client-side rendering was the first way of doing things. By no means is it perfect. Like, it represents some problems, and then server-side rendering came along to say, hey, we think we can solve those. And then static rendering came along later to say, hey, I think we can solve the problems of server-side rendering. And none of these things are kind of perfect. So basically, in a single-page application, when you go to the front page of the application, the very first thing you're downloading is a piece of HTML, and in that piece of HTML is just a blank screen. There's nothing there, but it says, I need you to go get this piece of JavaScript. That's the most important thing you need to do. So you start downloading a piece of JavaScript, and the JavaScript starts to execute, and then its job is to say, hey, I want you to take that blank screen, and I'm going to render something onto it, and then your app is born. That's client-side rendering. So what's happening is you download a blank page. That's the HTML that you have. You run the JavaScript, and voila, your app pops up. Now, downloading the JavaScript is expensive. The app, it can be really huge, and that's going to cost you time, money, whatnot. The other big problem is search engines. So we all care about getting our websites indexed by Google, and this isn't true anymore. Google has solved this problem, but in the initial days of single-page applications, the Googlebot would come along, download your blank page, and it wouldn't bother getting your JavaScript and executing and running it. So it would judge your site based on this blank page, which is pretty worthless. And so your single page application is not going to do well in Google. And that's a big problem. So server-side rendering was born. It was, hey, we can do better than this. We can actually render this site, just the front page, like the one page you're looking for, we can render that on the server. And so we won't send you down blank HTML. We'll send you down fully formatted HTML. And then we'll still ask you for the JavaScript application, which is the React app. You'll still have to run the JavaScript. You're going to boot up the application. And then it does this process called hydration, where it says, hey, we know we've got components already rendered on the screen. We've got HTML on the screen. Hydration is saying, okay, we've got this fully loaded app in the background. We've already got HTML on the screen. We need to merge these two things together. We're going to hydrate what's on the screen with our React application so that we can now start syncing things up. So when people click on buttons, React wakes up and says, oh, okay, I now need to render this component. I now need to render that component. So this was like, oh, great, server-side rendering is going to solve the problems of search engines. And then Google came along and said, you know what, we updated our Googlebot, and now it can download your JavaScript and it can run the React application, and you don't need to worry about server-side rendering anymore. We're good there. Now, I'm not sure about other bots like Yahoo bot and the Bing bot, and there's thousands of search engine bots. But Google has told us, they've unveiled the secret sauce, that yes, they will render your React application and have a look at that code, and they will judge your website accordingly based on that. So we don't have to worry so much. So that's like one argument away from having to do server-side rendering. Server-side rendering it adds a lot of complexity to your application, because now in your JavaScript code, when you're writing your application, typically you might do things like, I want to access a property of the window object, which only exists in the browser. It doesn't exist on the server. There's no window object because there's no browser on the server. When you're doing server-side rendering, you're doing it inside of Node.js. There is no browser. So typically you have to have a lot of if-else statements in your code base to say like, hey, if I'm on the client, and then I can access window and do this thing. Else, if I'm on the server, then I need to access the file system and do this thing to get the piece of data that I want. So it ends up making your application kind of messy. And so I should touch on the third thing, which is pre-rendering or static rendering. And that's when you take every permutation of every piece of state that your application could come up with on the back end, and you render it before any requests show up on your web server at all. And then when a request shows up to your web server, you say, oh, you're looking for this state of an application, and you're asking for it based on a route that you've chosen. And I already have that state of the application rendered. I've saved it to a static HTML file over here. I'm just going to send that back to you. And so it solves the problem of client-side rendering in that you're not going to get a blank white screen at the very beginning, and then you have to download some JavaScript. You're going to get some actual content. And it solves one of the problems of server-side rendering, which is that rendering on the server is actually expensive. Rendering on the client is expensive. Rendering on the server, just rendering in general, is kind of an expensive operation. So rendering on a server is expensive, and I have a pretty good horror story of how it actually took down some web servers at one point.
Let's hear that. Although I want to be clear, of these three approaches, client-side, server-side, and I guess static, which is Next.js enabling? Can you do all three with React alone, or which is Next.js providing, I guess?
Next.js gives you the ability to do all three. It helps make the server-side rendering easier. It removes some of the boilerplate stuff for you. It can do all the static rendering for you, and it depends on how you set it up. My preference is still client-side rendering in most cases, and then pre-rendering for some other cases. I'm not a huge proponent of server-side rendering. And that's going to surprise a lot of people because Next.js sells server-side rendering really hard. We do this for you, and it gives you some benefits. And there are some benefits there. But some of the problems with server-side rendering is your application is not actually functional and useful in the browser until you've downloaded that expensive piece of JavaScript and you've hydrated your application. So yes, you will get that first paint really quickly and you'll see some content on the screen, but nothing's going to work. None of your buttons are going to work. Your site's not interactive until you've downloaded the JavaScript bundle and hydrated that application. So there's a moment of frustration for the user that happens there when you're staring at something but it's not working. And so maybe you solve that with loading screens and whatnot. One of the bigger problems with server-side rendering that I encountered at a fairly large company is that it doesn't scale well, or we couldn't find a way to get it to scale nicely for high traffic sites. You have to realize that to render React on the server, you need to use Node.js. That's the only way to run JavaScript outside of a browser is using Node. So depending on whatever your server is, and we didn't have Node servers in our case, but even if you did have a Node server, I think you would still have this problem. So first of all, we didn't have a Node server. Our web servers were typically running .NET sort of stuff. So a request would come in to say, hey, I want this web page. .NET would go, okay, I need to fire up a Node instance. I need to say someone's looking for this route. Node would have to fire up our React application, render it, send it back to .NET, and then .NET would send the server-side rendered version of the page plus the JavaScript application back down to the client. So right away you can go, hey, there's this step you have that's kind of expensive getting in the way, and it's .NET firing up Node just to render a page and then sending that back. So let's just assume for this example that we don't have a .NET server. We're talking straight to Node. So Node is our web server, and a request comes in and says, hey, I want this page. Node says, okay, fine. I need to boot up this React application, do a render, and send it back to you. The problem is that Node and all JavaScript is single-threaded, which means it can only do one thing at a time, can't do anything else. Now, on a high-traffic website, and I said renders are expensive, remember, so you got a request coming in. Node says, okay, I need to stop everything else and I need to handle the rendering of this application. On a high traffic website, if another request comes in while Node is doing that render, then it has to wait. So it gets queued up. And on a really high traffic website like the one I was working on, a couple 100,000 requests would show up during the rendering of this React application. So now these couple 100,000 requests are waiting because there's only one Node instance that can only do one thing at a time. This is a big scaling problem. So to get around that, you can scale up Node. You can run one node per core of CPU that you have on your web server. So you can throw money at the problem and just increase the number of web servers you have, increase the number of cores on the web servers you have. But you end up getting into round robin problems. So to do that properly, you have to have some sort of scheduler built into your web server system saying, okay, I need to find a Node instance that's free. And I'm going to send this request to that node instance. And then the next request I'm going to send to the next free node instance that I have. And when I finally run out of node instances, then I have to use some sort of queue. This makes the whole problem way more complicated. And all you're doing is what are you saving? Google can handle your client-side rendered application perfectly fine. And Googlebot is the one bot you really need to care about in your website. So that problem's kind of been solved. Even if you are sending down a server-side rendered page to the user, they're still going to experience this moment of frustration because they still have to download your JavaScript application in order for this static page to become interactive and useful. And so at the end of the day, I made the call of let's just get rid of server-side rendering. It's adding all these if-else statements to our code base. So it's making our code base bloated and gross. We're not Node experts, so we don't know how to scale Node properly in order to fulfill the needs of a high traffic website. At the end of the day, we went with client-side rendering. I'm happy about that decision. And I kind of, and anytime anyone suggests server-side rendering, I kind of go, yeah, it's maybe not such the greatest thing. I mean, I know it's sold to you as like the savior of all the problems of client-side rendering, but it comes with a whole bunch more problems. So I'm going to stick to client-side rendering. And I will do pre-rendering, but that only works for cases where you're not going to have like a very interactive dynamic page. So pre-rendering is great for blogs, something like the New York Times or something. If they're just printing up news articles, they just need to render that news article once. There's nothing on that page that's going to change. So you just render it once using a React system, and then you can serve that page statically. That's a great solution for those sorts of things, but it won't work in like a chat application.
So it sounds like there's a lot of options, and maybe the trade-offs depend on the specific application as usual, I guess. One of the things you mentioned a few times is sort of the size of the JavaScript bundle or just the JavaScript program that you have to download. And I know another Next.js feature is code splitting. Is that a different way to address this fact that the page is not ready to use if you're able to split your code up?
Yeah, absolutely. Code splitting is essential for every React developer to kind of figure out and master. Now, you can do this without Next.js, but Next.js does it for you and makes it really easy. Without Next.js, you have to become a Webpack guru, and Webpack is kind of the old way of building React applications, and it's a kind of complicated framework to kind of master. And you could also use, there's something called React Loadable, and there's another React module. So there's a bunch of different ways to do code splitting. Before Next.js, I was using React Loadable, which allows you to define a component as a dynamically loaded component, which inserts a split point into your application. Code splitting is basically taking your React application, which is rendered down to a single giant JavaScript file, and breaking it up to say it doesn't need to be one JavaScript file. It can be lots of JavaScript files. There's no need for me to download the entire website if I'm only going to look at one page. I only need the JavaScript that renders that one page. And so you use code splitting to achieve that. You can, let's see, Next.js will come along and it will cleverly decide, hey, these components are mapped to this route. And so we can split them off. And we know that if you're going to this route, you only need these components. We'll package all that up into one little smaller JavaScript file. And when you go to this route, you'll just need that small file. When you go to the next route, you can download the next little JavaScript file that you need. So you're making essentially more network requests and downloading more files, but they're all a lot smaller. The net effect is you have a snappier, faster, seemingly faster site because you're not downloading the entire world to look at one thing.
As long as we're talking about optimizations related to performance, there's another Next.js feature related to image optimization. Is that something you make use of?
Yeah, that's something. So when we flipped our application over to Next.js, one of the exciting things was making use of the Next.js image tag, which offers a lazy loading feature for you. So images are generally also expensive things on web pages. And like the goal of a web developer is you're trying to figure out, how do I give you the biggest awesome experience for the least amount of bytes sent over the wire? So images give you a big bang for your buck. Like they look great, but they do cost a lot. And so you want to load them lazily, which basically means if I've got a whole web page on the screen, the bits off the screen is known as below the fold. So if there's any images below the fold, I don't need to actually download them unless I scroll them into view. Or if I get close to scrolling them into view, then maybe it's a good idea to start downloading them. Let's say I have a massive page that's really, really long, and most users never ever get to the very bottom of it. You don't need to load that image that's hidden on the very bottom. There's only like 2% of your users that are ever going to get down there. And so lazy loading solves that problem. So those 2% of the users, they will scroll down as the browser approaches getting to that image. Next.js will say, okay, we need to download this image now. So it basically means you only download the stuff that you are going to look at and see, which is a big savings. Next.js also is able to take your images and size them up accordingly for the screen size that you're on. So potentially you'll have people coming in on mobile phones, people coming in on desktops. They're going to want different sized images. Next.js will handle that for you and make sure that you're downloading the appropriate one so that it fits into the right place.
Before we move on to your migration story, one last Next.js question. I'm just wondering if there are any developer quality of life features that Next.js in particular provides that just make sort of the day-to-day development easier. I guess one I have listed here is a fast refresh. Is that different from React itself?
Oh, yeah. Okay, I could talk about that. So in terms of the developer's quality of life, I would say Next.js gives you a nice way to organize a React application, a nice standard way to organize a React application. So if I have a Next.js background and I come to your Next.js app, I'm going to know where to find things. There's kind of some opinions on where things are stored. Like all the routes are stored in a pages directory. I know where to find configuration stuff, so how to config the website itself. And one other really fantastic thing that Next.js does well is called hot module reloading, or hot swapping, I think it's also called. But basically, when I'm developing a React application locally on my own computer, I generally have the code in my VS Code IDE or WebStorm or whatever, and then I have the site running live in a browser. And as I make changes to the code, I want to be able to re-render that in the browser really quickly to make sure that I'm coding properly. Hot module reloading is a promise that React gave to the world when React initially came out, but it never worked well. Or I mean, it worked for a little while and then it broke and it became really frustrating. And basically what you want to happen is you want to be able to load up your React application in development mode so that it's talking to a special little server in your development environment, which is mapped to the code in your IDE. So the second you change code in your IDE and you hit save, boom, the React app goes, hey, something's changed. I'm going to re-render myself. And so you get that instant gratification of, oh, I changed something in the code. I see it in the React app. Hooray. That's called hot module reloading. You don't have to rebuild your whole app manually and relaunch the app to see the change. It just happens right there for you. And this came with React when React first came out, and it always notoriously broke in the first few days of starting up a new React application, and people were always scratching their heads of, why did my hot module reloading stop working? And it was usually because you installed some module that did something funky and it broke hot module reloading. And I spent so many hours chasing down, why does hot module reloading stop working in our application? Next.js does, I don't have to think about it anymore. It just works. And I can install modules all day long. And I don't know what secret sauce they've done in there, but they've done something magical that just makes hot module reloading working. It's a huge headache when it doesn't work because it's such a glorious feature for developers to have. So that's definitely a bonus of Next.
Yeah, in my career, I've had the gamut between essentially hot module reloading, even for a desktop application, to the opposite, where it's extensive restart time each time you make a change. And it's certainly one of those things you really enjoy when it's a short edit test loop. It's really nice.
Yeah.
Okay, let's move on to your migration story. You published a blog post, Moving House to Next.js, in October 2022, and we'll link to that in the show notes. But let's talk first about what application was this in general terms. What was the scale of it? What did the application do as far as databases or images, or what was sort of the requirements? And then what limitations you were bumping up against when it was React only, and kind of what pushed you over the edge to make the move to Next.js?
Yeah, so I'm working for a company called BenchSci now, and our flagship product is something called Selector, or Reagent Selector. It helps scientists choose which sort of reagents they want to work with in their scientific experiments. That application, it was the first application that BenchSci produced, and it was written in React, and it was done using vanilla JavaScript, and it didn't use Next.js. It was done before I arrived at the company. It works well, works fine. It does the job. And then years later, we built another suite of applications, which we've just launched this past year, or we just announced them. They're called Ascend, and they are a suite of a few more applications. And in building those, they all kind of happened at the same time. And another developer before I arrived at the company said, hey, let's use Next.js for these, for all the benefits of Next.js. It's, we're going to build a suite of brand new React applications. We can do it all kind of under one banner in Next.js. We'll get all the benefits of Next.js. We'll get the routing. We'll get the hot module reloading. We'll get the organization. We can do server-side rendering if we want to. I arrived at the company and quickly put that to bed. And anyway, Next.js was great. Lots of people could get behind it. We would have some opinionated ways of how to structure a React application. And so the new Ascend application was built using Next.js. Hooray. But then we were at this crossroads where we've got our flagship application is still React, but done in vanilla JavaScript, whereas our new stuff was actually written in TypeScript using Next.js. TypeScript is a typing system that sits on top of JavaScript. So JavaScript is not a typed language. It's a dynamic language. And that basically means that when you instantiate a variable, you can assign an integer to it, and then you can take that same variable and you can assign a string to it or an object to it. It's dynamic. That's nice because it's flexible, but it can cause a lot of bugs, and it's not really, I would never recommend it for like an enterprise solution. I'm a big TypeScript convert. I think variables should be really rigid and statically typed so that they can't change, and you should be able to know, functions should know exactly what sorts of properties or parameters are being sent into them. What is the shape of those parameters, and not guessing. TypeScript solves all these problems. Anyway, we wanted to take our bread and butter flagship application, move it into Next.js so it's aligned with all of the other new apps that we've built, and have everything under TypeScript and have everything under Next.js. So that was the goal of the migration situation. Before we had done this, we basically had two apps. We had a Next.js app and we had the selector application. And we had to use an Express server so that when you come hit our website, depending on which page you went to, you would get one of two single page applications. You'd either get the selector app or you'd get the Next.js app. And this, of course, is not optimal because as you're moving through the site, you could stumble upon a brand new single page application. Loading up a single page application, the worst part about it is the initial load of the application, the first 3 to 5 seconds of loading that application up. Now, a second on the internet's an eternity, so you want to minimize those. And so having to go, as you're moving through a website and you hit a brand new single page application and you have to load up a whole thing from scratch, that's painful. So it's not a great user experience. We had to use an Express server to decide, oh, you're going to this route. Okay, well, actually, that means you no longer are in this single page application. You now need to be over in this one over here. These are all pain points for our users, and we wanted to remove all of that. We wanted to make the site feel a lot snappier and faster. And we didn't want to have a Frankenstein experience of some of the stylings and components and ways of doing things in one application don't look 100% the same as they do in the new application. So as you're moving back and forth, you'll notice, oh, this button has square corners, but this one has round corners. That's odd, jarring. So you want to be consistent across your application. So there's another reason to do the migration.
I was going to ask about the Express server. Is that essentially routing, but at a higher level than within an application? Or what is the Express server?
Yeah, so Express is a web server written in Node.js. And basically, we used it to serve up whichever single page application you need. When you move fully over to Next.js, you don't necessarily need a web server at all to make any decisions and, dynamically serve you a piece of content. With Next.js, you can just serve up a static file. You say, oh, you want this route? Well, we're just going to give you this single page application. Oh, you want this route over here? Oh, well, we're just going to give you the same single page application, which is just a static file. You just need to download an HTML file and a bit of JavaScript, and you're off to the races. But in the way we had the app set up before, the two apps set up before, sometimes you'd have to flip back and forth. So, oh, you're on this route? Okay, there has to be some brains thinking, okay, that route actually means you need to go to this single page application. That route means you need to go to this one over here. So because you need a piece of brain work in there, you need to have a web server in there that has to make a decision. There has to be something that's doing some logic. And so that's what we use the Express server for. We also had to outfit links inside of the application. So let's say you were in the old JavaScript application, the non-Next.js application, and you clicked on a button that took you to the new one. That button had to be clever enough to know you're going to a route. It's not an internal React route. It's not in my application. You have to go up to the Express server to figure out that you actually need to switch over to a brand new single page application. So we had to put logic in the app so that each link knew, am I just re-rendering a different state in my own application, or am I leaving the app and going to another app? We could get rid of all that logic and make the app a lot simpler when we get everything under the banner of Next.js.
So this may or may not be related, but I think you mentioned Launch Darkly in your post, which is a feature flag management system, I guess. Did that play a role in this migration in terms of being able to selectively make these kinds of decisions or selectively turn on functionality?
Yeah, Launch Darkly it's typically a split testing system so that you can actually launch code into your application without it being turned on for all of your users. So just some of your users get to see new code. And typically people will use it when they're rolling out brand new features and they want to figure out, I want to present this feature to just a few users, not all of them. And I'm going to analyze how those users behave on this new feature before I decide to roll it out to even more users. You can also use Launch Darkly as a feature flagging system. So you could essentially turn it into something that says, you are a user of this type of role, therefore you get these sets of features. We're going to orchestrate all of that inside of Launch Darkly and enable you to only see certain things on your website. You could use it in a blog if you have content that only certain paid users wanted access to. You could potentially use Launch Darkly to determine, do you have the feature flag that enables you to see this content or not?
So in terms of things that changed, switching this flagship application to Next.js, did routing change, or what was your method of doing routing before, and what did you change to?
Yeah, the old legacy application had React Router installed in it, so the routes were programmatically inserted into the application. Next.js handles that piece for you, so you don't have to programmatically put them in your app. You just have to set up the right file folder structure. And so that's what we had to do. We had to make sure that all of the routes represented in the React Router, and they were a little convoluted because you can have routes inside of routes, and you can have components that are introducing new routes, and the old application kind of had a bit of a mess there where it wasn't, usually when you set up a React Router, I've seen it done where it's all kind of done in one file and all your routes are defined in one place. But our legacy application didn't have that. I don't know why. I wasn't around when whoever decided to do that made that decision, but it's a little tricky to figure out what are all the possible routes that this app accepts and can render. We had to do a little deep dive to figure out what they were. And once we figured them all out, we then had to transfer them over to Next.js and place them inside the Pages folder. So every Next.js app has a Pages folder, and underneath there are all your subfolders that map perfectly to your routes. And one of the things that I like doing for a Next.js application is I like to just make sure that that Pages folder only really contains routing logic. And so when it finally gets to like, hey, you're going to A/B/C, so C needs to render a component, I call that a scene, not a page. And the reason why I call it a scene is because I used to work on an application with a bunch of Android developers, and their terminology is scenes. So they don't talk about pages. Android apps don't have pages, they have scenes. And because I'm also building an application, but on the web, I said, okay, I'll adopt that terminology. I'll call it scenes. Granted, though, in Next.js, it's under a Pages folder. I've just realized that now as I'm looking at the folder structure of Next.js. So anyway, the point is, the thing I want to mention is that in that Pages folder, in Next.js, I feel like you should only really have routing logic in there. When you get down to rendering the actual C, the A/B/C, rendering the actual C, what you want to do, what I like doing is saying, hey, I want you to render the C scene, or I guess I should call it page now that I'm looking at how Next.js names things, but I want you to just render the C scene, and I'm not going to actually place that page rendering logic inside the Pages folder. It's going to import that scene from our global components folder. So generally a React application will have a whole system of components, usually organized in a nice global components folder. And I would make a scenes folder up there or a Pages folder up there so that all of my rendering logic is in one place and all of my routing logic is in another place. So that's just a nice way of kind of separating the different folders and what they're meant to do inside of Next.js.
Getting into some logistics, how did you divide up the team to work on this transition versus maybe continual work on the new applications? And how did you make the actual transition? Presumably it had to be done in one step or at least one day.
Yes. Yeah, that was. So we have to realize that we're taking a legacy application and we're merging it into a new application. And both of those applications are being worked on constantly by a whole bunch of developers all over the place. So we carved out a team to do the migration. There was like 4 or 5 of us, I think, and that was our migration team. And the first thing we did was we set up a bash script, or maybe it was a node script, that in our branch, it performed the migration. It took, actually, we probably did it as a node script now that I think about it, because there's a lot of details that went into doing that. But we basically just did a copy, paste, move files around. Actually, we had to use get move. You don't just copy paste files around. You actually have to get move them. The reason why you need to do that is because when you've finally done the merge, like on the day that you're actually going to do it, and you finally do the merge and you push that back up to your repo, there's going to be developers out there that are still working on old branches in the old world. And as soon as you make your merge, all their files aren't going to be there anymore. They're going to have moved over to somewhere else. So you have to use a get move operation to let them know that when they rebase and when they pull down the contents of the main branch, aka the migration, when they merge that into their old long running branch, get is going to say, hey, that file you're working on over there, I'm clever enough to know that it's moved over to here. Here's where you go to find it. So we're not going to lose the development work from those people. So we had to incorporate that into a node script, which we ran. And it was sort of like our dress rehearsal script. We would perform that. It would make the move. And then we would go in and see, okay, what's working and what's not working. We've taken all the code, we've moved it across. It'll be amazing if it just loads up perfectly on the first day. It didn't. So, but it was pretty close. Like you're taking React and you're putting it inside Next.js, which is also React. So there's a good chance that everything's going to line up. Some of the things that we needed to work on were transferring our image tags over to the Next.js images, transferring the way we used to do linking in the old app to the Next.js links, which are a little more clever. And then some configuration stuff. So sometimes links, like I said, would be shouting out to an Express server to figure out, do I need to actually switch to a single page applications? We don't need to do that anymore. So we would have to add some stuff in this dress rehearsal script that would say, okay, I'm going to rip that out and put it somewhere else. Your runtime configuration sort of stuff. So how you inject configuration into the app, depending on what environment you're on. When we build our application, it runs in our local development environment. Then it goes into what we call mainline, which is like a development environment where everyone's changes meet each other for the first time. And we find out what happens. And then from there, it moves to a QA environment, and then to a staging environment, and then finally to a production environment. And for each of those environments, you need to inject a bunch of configuration into the application. That was done differently for the 2 different apps. And so we had to migrate those and merge them together so that they're working properly.
I think the post might have mentioned public runtime config. Is that a type of configuration for Next.js or for?
Yeah, that's a mechanism for adding configuration to a Next.js app. There's a couple different types of configuration. There's configuration that you statically build into the application at build time, but you want to build your React application once and then deploy it to different environments and have it behave differently on those environments because it's in that environment. And to do that, you need to inject public runtime configuration into it. So it's saying, I've built the code. I'm not going to change the contents of the code anymore. But now that you're on the QA environment, you need to talk to this server instead of that server. And you do that through public runtime config.
One of the last sections in your blog post, I think, is called Moving Day. How did that go when the final transition was made?
Yeah, it was great. And it was stunningly great because we took a ton of code, like thousands and thousands and thousands of lines of code that's still being actively worked on. And we moved it from A to B. And there were no major blowups. Like we'd gone through the dress rehearsal script so many times and we'd done that move, and we created a special QA environment just for this move. So we would do the move, we'd take that branch that had everything merged together, we'd push it up to this new QA environment, and we went through it with a ton of manual QA folks, and a lot of developers went through there like looking for different bugs. And then whenever we found one, we would incorporate that back into our migration script, until we got to a point where we're like, yeah, this is working fine. The brand new, like the QA server that we have it running on, we can't seem to find any bugs, so let's go for it. And so we picked a date. We announced to the whole company, okay, we're going to do the migration. It's probably going to take us, 10 minutes to like do the merge, and then we need to deploy it, which takes another 30 minutes. And then we'd like to do a sanity check for like an hour or two just to make sure that nothing's crazy. And then you can go back to work. So we kind of picked a day. We told all the developers, just take a couple hours and do something else for a second, and we're going to deploy this and see what happens. And it went great. Like there were no major bugs. I was really stunned. I was like, wow, we did such a good job at building this nice dress rehearsal script and the whole flow of putting this up on a QA server and testing it out before we unleash it upon all our developers. And so, yeah, it was a big success, I'd say.
What were the concrete advantages that most surprised you or that you were just most impressed with in terms of the transition as far as how the users perceive the application, maybe performance or otherwise, or as far as developer and continued development? Basically, what was the net result here for you guys?
Well, clearly, like one of the big advantages of doing this was that you don't have this Frankenstein issue of jumping between two different apps. And so you have this like loading problem that happens as you're bouncing back and forth. And in our suite of applications, you would typically bounce back and forth between these two things a lot. And so having that jarring experience was gone now. So the app felt a lot faster. The other really big thing, and this I think was the major win, is our TTI went down by a lot. Now, TTI is time to interactive. It's what I think is one of the most important metrics in any single page web application that you're building. And it's the time that it takes for the first byte of that React application to touch your browser until the application becomes interactive and you can actually click and do things on it. You're aiming for that to be between 3 and 5 seconds. And I think in the old days, ours was up to like 7 or 8 seconds or something. But anyway, when we finally got everything moved over to Next.js, because of code splitting, automatic code splitting, that was the big thing. Our legacy app didn't have any code splitting in it because no one bothered to kind of figure out. It's a hard problem to solve and no one bothered to figure it out. We got it for free in Next.js. When we move everything over to Next.js, we saw like a 40% improvement in our TTI, which is actually a decrease because you want TTI to be low. And that to me was like the major win for us in that your application loads a lot faster, which gives you just a tremendous boost to your usability of the application.
And going forward, I'm guessing it's an advantage to have one style of applications. So that's going to make development easier.
Yes, absolutely. So now we can be more consistent in our components. We can share components. So the legacy application can now use components from the new application. It's all just one application now. So there's a much better ability to be sharing things back and forth. We're going to be a lot more consistent. Since this, we've now developed a nice design system that allows us to make sure that all the facets of the application are using components out of the design system so we remain nice and consistent. And so now there's this nice uniform experience across everything that BenchSci is providing.
Let's start wrapping up. Can you speak a little bit about the Next.js community, the documentation, resources online, how you feel that is, especially for someone new to Next.js?
Yeah, I think Next.js is a very successful and popular React framework, probably the most or one of the most successful React frameworks out there. And that's definitely due to documentation. You don't get to a good place in developers' hearts without a great documentation system. There's an amazing Next.js developer community. That's also a big attraction to why you would want to use it. When you enter into a new framework, you want to be able to know, at some point I'm going to get stuck. How do I get unstuck? What are the best ways of getting unstuck? And the community for Next.js, the documentation totally help with making you feel like, yeah, this is a safe move. Let's do it.
How about for someone starting on a greenfield, brand new application? Are they taking on more to start with Next.js, or is that going to simplify it if they use it from the beginning?
So in the olden days, there used to be this thing called Create React App, which nobody's using anymore. But it used to be the standard, like, oh, you want to make a React app? Just download Create React App and get that running, and that will get you a React app up and running nice and fast. I would never recommend that anymore. And I would totally recommend Next.js. So now you really just have to do like an npm install next, and it'll load up an application for you and everything just works. And it'll give you a nice front page, which of course you're going to change to suit your own needs. But it's all there. Great documentation to show you how to put things together and move around. So yeah, Next.js is an awesome first stepping stone for someone who wants to make their first Next.js app. It'll help remove a lot of the difficult, confusing parts.
That sounds great. Thanks so much for sharing all this with us. Is there anything you'd like to say about where to follow you or learn more about any of this online? And we'll put any links in the show notes.
Yeah, I mean, you can find me on Twitter at Timothy Beamish. And of course, the link to the blog post is in there. There's some more details of how we did things. Feel free to reach out to me on LinkedIn or on Twitter if you have any questions about doing something like this. I'm happy to help.
Thanks so much for talking to me today.
Yeah, thanks. It's been great.
This is Philip Winston for Software Engineering Radio. Thanks for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.